Hello, everyone. This is Harshit from Appknox. I've got Shubho and Nishant as co-host today. So, topic for today's session is on how to perform API security testing. So, let me know if like. I think my screen is visible to everybody. So, I'll just get started with our webinar today. So the topic is how to perform API security testing. I'll not take too much of time, and let's introduce the speaker. So I've got Shubho Haldar, who is CTO and co-founder at Appknox, and he's also founder of AFE, Android Framework for Exploitation. And we've got Nishant, who is a senior security researcher at Appknox. And Nishant has also participated in a lot of bug bounty programs and all. So our topic for today is, as I mentioned, API security testing. So briefly the agenda. So basics of API security testing. That'll take hardly 2 minutes to just like position what exactly API security testing is very briefly in theoretical way. Then we'll move to live webinar of like what all tools can be used and that live demo of using those tools. So let's move ahead. So basic of API security testing. So since we all know that APIs connect to our most intimate and sensitive data, so it is very important step of security assessment to check if APIs are secure or not. Some of the basic rules for API security testing are that if you are giving any input to API, you must the API must provide whatever expected output it should give. So you should check that while doing security testing. Then inputs, whatever input are allowed, should be in specific range, and any value outside that range should be rejected. Input of any incorrect type must be rejected, and any input that is empty when empty is not even required as an input should be rejected. And any incorrect size of input should also be rejected. So these are some of the basic API security testing rules that I'll get started with. So these are tools that we are going to use. So we'll be using SQL Map today, Burp Suite, and Charles Proxy, uh, dir search, Git tools, SureGit, and GitRock. Aquatone, WP Scan, AWS S3 API, Postman, and Patater. So I'll pass this call to Shubho and Nishan to continue and probably show us more about or probably explain briefly on what we are doing on, and post that they can like get started with the live demo and all as well. Yeah.
Yeah, thank you, Harshit, so much for the brief introduction. So you might have questions while we are doing this webinar. I would request you guys to select the Q&A option below in your Zoom panel. If you are watching it from YouTube, Facebook, or any other social media site, you can obviously post your question in the comment, and we'll try to answer those questions while going through the webinar, or at the end also we'll try to answer. But no doubt all those who have signed up for the webinar will get at the end of the webinar a list of all the questions which were asked along with all the answers, so that you will not miss it. So to start off this webinar, uh, what we are going to do is we're going to divide this not in basis of tools for API scan security, but instead what I'm going to do is we are going to divide it in basis of uh, few sections. The first part of the webinar, we're going to talk about API level issues, and uh, and the second part of it would be basically the business logic issues. The third part would be the deployment issues. So in the API level issues, I'm going to talk about how we can use SQL injection, which is pretty much easy, but how we can do something more, like some more complex SQL injection things. Then Uh, then in the other issues like SSDI, where we are going to inject few things in the template. Then we're gonna also show about excesses, but what about blind excesses and things like that? We're gonna showcase something in terms of IDOR and how we can use tools to use or figure out IDORs using the comparer or the intruder feature, or how to do brute forcing to figure out IDOR. We're going to use Charles proxy to showcase if if the application connects back using protobuf protocols or some binary protocols, how you can decode those protocols and how you can intercept those protocols and do an interception on top of that. Followed by Postman. So we're going to talk about how we can import request and responses from Burp and or Charles to Postman and create a collection of all the APIs which you have tested. So these would be the API level issues which I'll be talking on the first part. The second part which I'm going to talk about is the business logical issues, which will be like something like price manipulation, how we can manipulate price, not a very simple manipulation, but something complex, race condition between different logics. So this would be the business logical issues which we'll be talking about. And the last would be the deployment kind of issues, like you may be deploying your APIs in your server, and you might be using Git to do an automated deployment and things like that. In that case, how we can use different tools to figure out whether your deployment itself is proper or not, whether whether we can figure out secret keys in your deployment, or whether your code base has some security issues and things like that. So that will or let's say you're using AWS services, whether your S3 buckets are problematic or not, and things like that. So that would be the deployment kind of issues. Yeah, so that is the thing. So now what I'll do is we'll directly jump off to how we can do all of this testing. So I have with me Nishant, who is going to showcase the first part, which is the API level issues. And in the API level issues, so Nishant is going to take it ahead from here.
Very good. Hi guys, this is Nishant from Appknox. I work as security researcher with Appknox. And so yeah, as Shubho discussed the agenda for the webinar, let's quickly start with the webinar on discussing multiple security issues. So the first issue which we are going to discuss is SQL injection. So yeah, SQL injection will be talking about how to detect SQL injection using Burp and how to automate this and so on. So basically SQL injection are categorized into multiple types. One is error-based, one is blind, and so on. So here we'll talk about error-based SQL injections. And SQL injections are basically caused by an application not having input validation in the server side, and it accepts any SQL query as a proper input, right? So let me switch on my Burp. So my Burp is running. Here I enter character 1 or C2. So yeah, here we can see there is a post request which has been sent to the server on this endpoint xvwa SQLi, and the parameters, two of them are being sent, item and search. So to test for SQL injection, and that to error-based SQL injections, the first step in exploiting SQL injection is give a special character which the SQL DB recognizes and see if you're getting an error or if the application is throwing a 200 or it's becoming unresponsive and so on. Basically, let's just inject a quote in end of the search parameter here and try to send it to the server. So Here we can see there is a SQL error message. It says there is a error in the SQL syntax on MySQL server version and so on. So this is basically a litmus test to understand if there is a SQL injection, if it is potentially can be exploited and so on. And here, after this, we have determined that there is an SQL injection. We can give more queries like one or one equal to one and see how the server is responding. You can give something like this, and we have a error message and so on. So yeah, and instead of or, you can also give and or union with the syntax and see how the server is responding and what is the error message you're getting. So this is a time consuming process, and if you are working on an engagement which needs to be delivered on some particular day, you cannot expect the whole SQL injection to be done manually by yourself. That's why we have a tool called SQL Map, which automatically detects and exploits SQL injection, which has multiple other functionalities also, like you can run a command, you can upload a shell, you can dump the database, you can create a user, and multiple other things. So we are just going to showcase how you can use an SQL map to detect and exploit SQL injection. So if it is a GET request, so this is a POST request, right? So if it's a GET request, you just need to right click, copy as a URL, which is, yeah, copy URL, and you get the GET URL, and the ID will be in the URL, which the SQL map will recognize and it will exploit. But this is little different because this is a POST request, and there is a body with a couple of parameters, and there are multiple headers. So how do you run this into SQL map? So you just copy the whole data. You just copy the whole data into a text file, save it in your desktop, and run SQL map -r post.text -v.
It'll be SQL1.text, right? If I'm not.
Yeah, basically this SQL1.text is gonna start scanning the whole database from scratch, and it will take time. So we have already created a SQL post.text, which has, you can see, which is the same, which is the localhost XVWA SQL injection with the parameters item1 and such.
Okay, so just for people, some of you asked, oh, what is the application which we are using? So we're using an application called XVWA. It's an open source web application tool which you can also download it in your laptop. In this case, we use the Dockerized version, which was pretty easy for us to host it, and that has a lot of exercises which you can do. So we are taking the error-based SQL injection for this demo. Yeah.
Yeah. So basically, we can see here that SQL map -r is the text file which we need to include, and -v is verbose. So basically, it sent a couple of parameters. So since it is in verbose mode, we can see what is the payload exactly here. So it sent a payload called item equal to 1, and it made a SQL query, right? So I'm just highlighting that. It made a SQL query, and it determined that the database which is used in the backend is actually MySQL. So not only you can determine the database, but you can also determine what are all the tables inside it or columns present. You can also, for example, check what is the host name. Yeah, you just run SQL map with flag host name. So it is going to fetch the server's host name, which is this, which is this. And here, since it is in verbose mode, we again can see what is the exact query which SQL map sent, so that we can try to reproduce it ourselves using burp, or to tell the developers on how to exploit this or how to reproduce this vulnerability. We can use this as well. So that's the first issue, SQL injections.
So Nishant, I actually have a question from one of our viewers, and so the question is basically, uh, most of these queries which you are running in the SQL map would be blocked by WAF, right? Web application firewalls, which are there. So how can you bypass this WAF using SQL map or any other things? Like I still remember that we did an assessment on top of where there was an AWS WAF which they were using. So what did you exactly do to bypass those WAF?
Yeah, Subho. So basically, WAFs are just defense in depth, and SQL injection or any type of API level security threat should be patched in the API level instead of putting a WAF or adding additional level of protection. So why I say this is because, as you were mentioning, one of the assessments which we were doing, we had reported SQL injection to one of our clients, and what they did is they didn't actually patch the SQL injection by using parameterized queries, but they actually bought a AWS WAF. They were already using AWS EC2, so basically they bought WAF solutions as well, and they configured the WAF to block our SQL request. So when we rescan to check if it is a SQL injection is still possible or if they have fixed it or not, initially we were not actually getting any response from the server. But so basically, I'll just show you. So here, so say this is my request. This is the request, and this is, consider this is the server which has a WAF which blocks certain keywords like and. For example, consider it blocks and, or it blocks or union or whatever. So initially, what we tried doing is, again, we tried to reproduce by one and one equal to one. We sent it to the server. It just threw a 200 and it didn't show any SQL error message. But when we did something like this, which is not exactly a capitalized and, which is a smaller case A, capital N, and capital D, this will actually bypass the WAF because the WAF's configuration is to block and, which is in caps, or block and, which is in small. So if it is capital A and D or small a and D, that will be automatically blocked by the WAF. But since this does not match the signature of the WAF, this will get bypassed. So we figured out that, okay, they are using a WAF and we need to go about bypassing this. Again, doing this from scratch using just a proxy to fetch the databases, to fetch the usernames, it's extremely tedious. So we were actually going through SQL Map's documentation, and we found something really cool in SQL Map called tamper scripts. So yeah, so basically we found yeah, we found something called tamper scripts. So basically, what tamper scripts do is they have bypasses for WAF, or they have a custom. Say, for example, I'll give you one more scenario. Say your whole post body is being actually sent in base64. So how would you test that? You don't have to decode it every time, inject SQL payload, encode it, send it to the server, decode it. That's very tedious, right? So SQL Map has a tamper script which will automatically use base64. It will encode it and give you the results. So here in the scenario where I was talking about earlier, we use this. We used a couple of tamper scripts from the mentioned ones, which is between.py and
Yeah, so I think it would be like random case.
yeah, random case, exactly. So basically, we can see example, right? So select will be changed into SC, small l, small e, capital C, T. So these are very helpful in assessments, if that too, if the application is using a WAF. Also here we can see there is a bypass for blue code, which is a WAF solution. There are multiple bypasses, multiple tools which you can integrate, like the one I said for base64. And if it is blocking spaces and comments, how do you go about bypassing that? We just need to see what are all the tamper scripts which are provided by SQL Map, and I'm sure one of those tamper scripts should be useful to mitigate overcome the WAF or whatever is being blocking your request and not being fixed.
So one thing which you can do also is basically write your own tamper script. So you can so all of these scripts are written where you can basically go ahead and view what the script basically does, and you can use your own tamper scripts, like use your own way of bypassing it. But the first thing is figuring out if you are using some kind of WAF, is there a bypass to those kind of WAF? And then figuring out whether you can do a tamper script on top of that. Now we have a lot of questions over here, which is talking about the first thing which I got is this is a very basic thing for a pen tester, right? An example of an advanced exploitation in case of WAF scenarios, but for that we need to host a WAF to show a live demo, which is not possible in a webinar which covers a whole lot of other things, not only SQL injection, but what we will try to do is give you a direction where you can figure out how to go ahead with. We have our own group. We have a LinkedIn group itself where you can, if you want to dig down, deep into some, if you have questions regarding how have we ever experienced a WAF where we had bypassed, or if you need some help with scripts, we're happy to help you there in the group. But for the sake of time, we are going to just show this tamper scripts which is there, and this is how you can do it. You can write your own tamper scripts and go ahead with it.
Okay, so that's it for the SQL injection. So the next issue which we are going to cover is SSDI. SSDI or server-side template injection. So basically, currently there are a lot of templating engines, right? So for example, Jinja 2, there is a templating engine. Twig, there is a templating engine, which in a form accepts HTML character, which in a form accepts HTML input. But considering an application which is facing a client, which is facing a consumer, you do not want the customer to execute scripts on the basis of your server on top of your server or something like that. So here we can see the demo for SSDI. So the hint says that the template engine uses Twig, right? And the loader function uses Twig loader string, whatever. So the first step to figure out if there is SSDI is to check what type of templating engine is the application using. It can be Jinja, it can be Twig, it can be anything. And the next step is to figure out what is the syntax. So for Twig, we figured out that if you run, I'll just say run admin, right? So it says, okay, whatever I have inputted that in this box, it says hello, that string. So what if I enter, say, 2 multiplied by 5? It says 10. So basically what is happening here is I entered this payload, which got executed and is getting displayed in my screen. So basically this template, whatever we gave, is a multiplication for in that Twig engine, and it actually executed in the server side, and we are getting the responses hello 10 instead of whatever we inputted, right? So what is the threat here? What is the impact of template injection here? So a lot of templating engines like Twig, they also have a property where you can execute commands using the inbuilt template engines API calls. So here, so this is a payload which we figured out. So basically it registers a callback which executes and gets the command name in this filter, and this is ID, right? So basically what this does in the backend is it executes ID in the form of the web application, like in the context of the web application. So I just run this. And here we can see that hello UID 33 W2W3 data. So basically, we just escalated that template injection to run command. So basically here you can create a netcat shell, you can upload a file, you can download files, and so on. So this is this second thing, server-side template injection. The third and last type of injection we are going to talk about is blind XSS or blind XSS. So basically, blind XSS, we know XSS is, so just to explain XSS firstly, XSS is something like when the input is not actually filtered from the user and from the client side. That input can be either stored in a database or it can be just uh, previewed, or it can be just showed to the user without getting stored in the database. So if that input, say the application is written in HTML and JavaScript, and the input actually accepts special characters, there is a way in which we can inject a script payload, right? So we can inject a payload which will automatically execute that script in the context of the web application. So if that data, so for example, if I inject a script in say, consider this, enter your message here. I enter a message here, and that message gets stored in the database. So basically, whenever a query is sent to the database to fetch this message which I saved, that script will be executed. So this is crossed, and this is cross-site scripting, and store and reflector are two types of cross-site scripting. The one which we are going to.
So, Nishant, I'm going to stop you over here. So, for the SSDI, I have a few questions from the users which I wanted you to answer. So, can you go back to the SSDI demo which you were showing? So, one of the question which I got was, how does 5 into 2 give you 10, and what is what is its significance, and what can you do with that?
Okay, so as we were explaining, so each of the templating engine has a different set of syntaxes, right? So in Twig templating engine, so the basic syntax is you need to use brackets, and whatever you need to execute, you need to, whatever you need to pass a command or execute a command, you need to pass it in between the special brackets. So basically, say in the templating engine, you're getting input from the user and you want to multiply, or you want to add those characters or multiply these characters. You basically, you do, instead of doing uh, 2 into 5, you're gonna, what you're gonna do is you're gonna copy that into that special character, special brackets, and you're gonna execute this. So this is the format for Twig's templating engine. So all the syntaxes will follow the specific format. And here we can see this is getting executed in the server side. So what is the impact here is that, as we were discussing earlier, most of the templating engines has a functionality, or it has a inbuilt API calls to execute commands, right? So using those, we can actually execute commands on the server where the web application is actually hosted. So for instance, so this ID is a ID command which is being sent to the server to be executed, right? So this ID, if I, one second. If I run ID on my system, so it's going to show who's the user who's actually logged in, what is the GID, UID, and so on, right? So here I'm going to send the same command to the web application server and asking it to execute using the filter, which is the syntax for that specific template, which is Twig, right? So I'm going to send this, and instead of hello, whatever we have inputted, the whole template syntax which we sent to the server got executed. And here we can see that ID got executed in the server side, and it is getting printed in the client side. So basically, this is a command injection. Yeah. So
Okay,
yeah,
got it.
got it. Yeah.
Right. While we were talking about cross-site scripting, right? So again, so one of our attendee was asking that why is it named as an API security webinar and not a web-based traditional webinar where we are showcasing traditional vulnerabilities. I would like to answer that along with Nishant. So, for example, all of the vulnerabilities which we are showcasing in this webinar are basically vulnerability which exists both in web and API. So again, I'm not going to showcase how XSS happens, but there is a vulnerability called blind XSS, which you can basically pass it on an API and it might execute on the backend of a dashboard or some user. And that would be the example which we're going to showcase over here. So these are all vulnerability. This is the first part of the webinar. And most of this vulnerabilities exist in API level issues where mobile apps uh, communicates with the server. So things like that is where we basically come up with all of these vulnerabilities, which we see it in our day-to-day activities and in our day-to-day pen testing. So Nishant, why don't you go ahead and showcase how we do figure out that there is an XSS, there is something called a blind XSS, because in an API, obviously you do not have the UI to see, right? But you can obviously paste an XSS payload. Probably it might execute somewhere, but you have no idea. I think that's what blind XSS
Yeah,
is.
Shubho. So that's exactly what blind access is. To give you more context, I can give you an example on where blind access might exist. So consider there is a mobile or a web application. It is asking you for the feedback, right? So there is a separate column called feedback. You click on the feedback and it asks for the user email address and also the feedback which you need to enter. So this data will be sent to the server, and a customer representative will actually go through this feedback, right? So this, even if this has an XSS, you don't have any deterministic way to actually say that, okay, I have injected a XSS payload, but where will that execute? It is not going to get executed in the client side, which is in the browser side, because it is getting saved in a different application altogether, in a different database altogether. How do I determine if there is an XSS or not, right? So this is one of the scenarios where blind XSS comes in place. So blind XSS can happen in any of the payloads, any of the parameters. The data can be saved in a different application. It can be saved in a different database, and it might be also executed there. So to test blind XSS, we actually use a free tool called XSS Hunter. So basically what it does is it creates a domain name for yourself, and you can copy it. It generates a couple of payloads. So whenever that script payload is being executed, you'll get a email and you'll get a notification in the XSS Hunter app that, okay, your XSS has been triggered in this specific location, this parameter, here are the cookies where the application has, and so on. So select this. So this is how the UI looks. And under payload, we can see there are multiple payloads, which bypasses a couple of things, HTML5 payloads, and so on, right? So I'm just going to use the basic XSS payload. So here I'm going to enter in this. So basically what this payload does in the backend is, whenever this gets executed, say there is a customer representative which opens the feedback page, right? Whenever he opens this script gets executed and a callback is sent to this specific domain, nth-app.xss.ht. So that once this callback is sent, so we can determine that, okay, I got a hit from the customer server. So there is an XSS because the script got executed somewhere in the application. So I'm just going to submit this. So now whatever script we have entered, the source which I've entered got executed. Now here we can see that there is no pop-up or whatsoever. So how do you determine that? So go to
I think you need to execute it once more.
Yeah, so basically the XSS payload which we entered in this box, this specific box executed, and here we can see the XSS hunter is saying that, okay, I have figured out XSS for you, and I'm gonna just see the full report. So basically what it does is it takes a screenshot of wherever the XSS got executed. It can be an admin panel, or it can be anything. It takes a screenshot of that specific page where the XSS got executed. It is going to say where is the origin. Here the origin is in localhost. This is the IP address. This is the referrer, user agent. And one important thing here, what we have is cookies. So consider an application which has a login functionality and it is facing internet, and we have figured out a XSS. It will automatically send the cookies as a part of the header. So basically, we just need the cookies to log into that specific user's account. And yeah, this is how blind XSS works. So basically, we can create a report, we can see the screenshot, what is the victim IP, and so on. So yeah, this is XSS. So we discussed three different type of issues, right? So SQL injection, SSDI, and XSS, all or one or the other type of injection attack. So how do you prevent this? So the first step of prevention should be the input which has been getting from the user, like the input which has got from the user, that should always be sanitized in the server side. So it should be checked for special characters, database commands, or script tags, and whatever is not necessary should actually stripped and sent back to the user. And also whatever data is being printed on a page, that should be encoded so that it doesn't get executed. Yeah, so first we have covered a couple of injection attacks. The next one is IDOR, which is prevalent in a lot of applications which we have tested. IDOR, or insecure direct object reference. So the basics of this issue is so the basic of this issue is that whenever the application queries the database to fetch some data, for example, it can be profile data, the authorization is not happening based on the token, but on the resource identifier. So I'll so yeah, here we can see that there is a get request. We can see there is a get request which is querying for the item with the number 1. There is a session ID as well. So basically, the problem here is that the database is querying the data based on this identifier, which can be modified by a user who's in between the client and the server. So basically, if I send this specific query, which will which will show us the data of the item code XVWA0987, right? So what if I change the item number from 1 to 3? Yeah, here we can see there is a XVWA 4589, which is a completely different item. And so this is a very important step in securing your APIs, because all the you might use these type of resource identifiers in your applications as well. So a lot of times what happens is that the database, the query which is being sent from the client to the server and server to the database to fetch the data, they are just checking this parameter. What is the parameter which is passed from the client side? Is it 3? Is it 1? Is it 2? Or if it is a profile data, is it Nishant or Shubho at appknox.com? What is the email address being I want you to get the data for? So that should never happen. And always, once you securely log in a user and authenticate him and give an access token, that access token, so here, which is PHP session ID in our case, this access token should be mapped to the user ID and also user ID or whatever identifier which we are implementing. And this access token should be authorized to fetch the resources. For example, this authorization token can only fetch the resources of item 1. And if there is a second user who is actually buying item 2, that user's authentication token should be used to fetch item 2. So yeah, that's IDOR. That is again one of the most common issues which we figure out in our mobile application security testing. Yeah, so basically, say you want to say this number is pretty random, right? So item number is 1 and the next item number is 236 and the next item number is 552 or whatever. How do you check this? Like you cannot query a single item by item by item. That's not feasible, right? So how do you check this? There are two ways. Like one, just using burp, which we prefer. So using burp, you just need to send this request to intruder. So you get the attack target, port number, and so on. So clear this. So what is the parameter which needs to be checked for IDOR here? This is item, and what needs to be changed? The number 3. So you just add a payload here, payloads positions here, and you go to payloads. You choose. There are multiple different types of payloads. You can generate usernames, character blocks, dates, and so on. So I create a number here. I say I want to brute force from 1 to 20 with a step of 1. Here the minimum integer I gave is 1 is because it starts from 1 and the maximum is 20. So the max can be 20 and there are no fractions. So it's 1200. I want to brute force from 1 to 20 and I click on start attack. Basically, it will query from, see, there is item 1, item equal to 1, item equal to 2, item equal to 3. Till whatever number you give, the intruder is going to brute force and tell you, okay, these are all these data. Like you can see the response, you can filter the response based on 200, 300, 400, or 500. You can comment and so on. And also one more thing you can do is you can go to the options. You can set the number of threads. So if you set say 100 threads, it's going to take some of your resources, but it's going to be pretty faster than using 5 threads. So that's how you automate it. So we also have a different tool which not only is used for IDOR, but we use this for brute forcing user credentials in a FTP or a HTTP or something like that.
So, Nishant, we have a question from someone who was asking me, is there a way where you can brute force UUIDs with, instead of a simple integers to exploit IDOR or Bola?
Yeah, so basically it is to brute force a UUID which is like 16 or 20 bits. It's not feasible, right? It is going to consume a lot of resources. That is not feasible. But we have come across such implementations where there is a UUID which is like 30, 40 characters, but there was IDOR. How we were actually able to exploit the IDOR was there was a forgot password page, right? So forgot password page, I give the victim's ID. Say victim here is Shubho. Instead of my user ID, I give forgot password Shubho at appknox.com. What happened there was it was sending a OTP mail to Shubho, but it was also printing the UUID of Shubho. So from there, I was actually able to obtain the UUID of Shubho, which is pretty long. And in my get profile API, what I did was I just changed my UUID to Shubho's UUID, and I was able to see Shubho's data. So basically, the fix is not the UUID or changing the integer to something very random and pretty long, but the fix here, which needs to be implemented by the developers, is that the token should be mapped to the user and that should be authorized only to fetch his resources.
So you are saying that it should be a static, it should not be a static UUID per user. It needs to be generated per per session?
No, that's not necessary. It can be a static UUID. It can be a number like 1, 2, 3, 4 also. Like that doesn't matter. So as long as the logic is secure, as long as the access token is used and not the user identifier is used to fetch the resources, it's as simple as that. You can use number 1, 2, 3, 4, or you can use a 50-digit character or whatever. Yeah, that's the logic behind it. Yeah, so back to it, we were talking about brute forcing, right? Brute forcing, right? So one of the other tools which we frequently use here is this thing called Patator. Yeah, so this is a brute forcing tool which has multiple modules, right? You can brute force FTP, SSH, Telnet, SMTP, HTTP, LDAP, SMB. They have modules for multiple resources, like multiple services. So how do you brute force that? Is you just give Python, run it in Python, the file name. HTTP first is brute force HTTP based API, and I give the URL. Method is post here, and body, say there is a body with username and password. I give file 0 and file 1. I declare the file 0 here with whatever is the username, whatever is the password, dictionary, and so on. And here also I can also grep or reverse grep based on the error messages, based on the status codes, so that only successful results is what I'm looking for. So that's one more way you can actually brute force credentials or test for IDORs if it is pretty long.
Okay.
So and one more thing is that developers tend to use Postman a lot, right? So it's very easy for them to test APIs on if there is a failure, what is the body parameter sent, and so on. So basically that in Burp can be actually used along with Postman also. If you want to test using Postman, that is also possible. From Burp, there is an option as we saw earlier, right? So you copy as curl and you start Postman. You import it, paste raw text. Just copy the curl, whatever you copied from your Burp session. You just import it. Here we're going to see whatever Burp was actually showing us. There is a get request to specific IP. There is a parameter, there is a header, and so on. This can be used as well for API level testing. So the next one, which we are going to talk about, is gRPC. So actually, Shubho will be sharing the screen for that. I'm actually switching the screen from mine to Shubho's.
Okay, so coming back to the presentation once again. So what I'm going to talk more about is whenever we talk about API or API level security, there are things like binary protocols which also comes into the picture. For example, in this case, we are going to showcase a demo gRPC protocol and how you can basically do an intercept of this kind of gRPC protocol, perform a man-in-the-middle attack, and perform changing the parameter and things like that. So in this case, again, this is all related to a mobile app. So we have an app running in a mobile device, which I'm not going to show because I'm only going to talk about the API level issues. So in this case, I have my Charles proxy already on. So you guys can download Charles proxy, which is kind of free. And in Charles proxy, you can, for example, in this case, my proxy has started in 8081. And I'm going to start my server, and I'm going to, do a gRPC connection to my server. So if I do a gRPC connection to my server, basically, okay, I need to start the record. So when I click on start record, basically all the API requests which is getting will be recorded now. So again, I'm going to redo it once again. Okay, let me just clear this. And let's try to connect to the gRPC device once. Okay, I think I need to start my gRPC server, local 10. This is just like a sample app, and I'm running a server over here, and I'll try to reach this server using gRPC. Let me retry it once again with 8080 as a proxy, and let's do this. Okay, it is not yet coming, but what I can showcase is how we set this whole thing up. So basically, if you go to the proxy, you can basically import. So whenever there is a protobuf or gRPC kind of protocol which you are working with, you can obviously ask for the proto file or the schema file, and when you get the proto file or the schema file, you can attach those proto file or the schema file in the protobuf settings. So you can go to the protobuf settings, and these are the descriptive files which are there. So you can add more proto files over here. So basically .proto would be the file which you will be getting from the developers. You can convert this .proto file into a descriptor file using the proto language, and once you load these, so these would be the definition of the protocol. And when you do a man-in-the-middle attack on top of the protocol, you can basically see how the data is getting sent. So let's try once again, and I guess this time it should work. Let me just go to proxy. Let's go to proxy settings. Let me just enable the transparent mode, and also let me see. The SSL proxy should be disabled for this one. And let's see. Okay, at least some requests are coming. So for example, if this is the request which came, and this looks like some gibberish request, right? So in this case, what you can do is you can view the response as protocol buffer, and you can load what kind of descriptor. So just to give an example, like let's say this was a get balance request. So you can go to protobuf. Okay, let's try this again. Sorry, view request as protocol, so not response. So once you click on this, for example, let's say get balance response, let's say, but since the message is not proper, so it gives an invalid tag. So you can select, I guess this would be the other response. Okay, fine, but that is how you basically figure out protocol buffer based API. I'll just retry it once again. Let's see if this comes over here. Okay. Okay, fine. But I hope you guys understood how we can read a protobuf, protocol, and how we can edit those responses using Charles proxy. So what I'm going to do is I'll hand it over back to Nishant to talk about more on business level logics which are there.
Okay, so the next issue, which as far as now we talked about multiple level of API issues. The next thing which we are going to talk is business logic issues. Business logic issues are important to be tested in an application, because each of the application performs a different set of functionalities. For example, take Ola, for example, you can book a cab, you can cancel a cab, and so on. And if you take, for example, a banking application, it will have different types of business functionalities, like you can request for a check, you can pay, you can redeem an offer, and so on. So how do we go about testing business logical vulnerabilities? The first step is we need to understand what exactly the mobile or web application does, and what are all the critical components in a critical business logic components in that application. So consider the application where there is a payment option, and say it's a shopping cart, and how do you go about testing business logical issues in that, right? So
So what are you trying to show?
I'm just seeing the IP for the server which is hosted.
Okay.
Yeah. So this is an application which we had hosted internally for the webinar. So say there is a consider this is a this is a some application like a Flipkart or where you can add items to your shopping cart, and you need to pay using a payment gateway, and you get the order, right? So here the price data for each of the product is actually stored in the server side. Here we can see only quantity. You just can enter the quantity of how many items of that product you want, and the server is actually storing the price value, right? So here you can enter 1 or you can enter 2. So say I need to buy 3 items, right? I submit a query and it's saying 180 is the price which you need to pay, right? So when I enter 1, it is 60. So basically, like, what is the business logical issue you can find here? Like, what can you exploit here, right? So basically, yeah. So what can you do here is that instead of I enter a quantity, say 2, and I submit a query, it goes to the server. I can change that 2 to say 0.5, and it send it to the server, and it says that it is 30. So instead of calculating prices for 3 different items, it just calculated for 0.5, and you're going to end up paying less than for the 3 items. So this is one of the business logical issues which we face in a lot of banking applications or e-commerce applications. So business logical issues depend on whatever functionality being implemented, and you need to fuzz with different types of input, like it can be a negative, integer, float, and so on, to figure out vulnerabilities in that. Okay. Okay, so we have covered a couple of business logical issues and API level security issues. The last few minutes, we're going to talk about deployment level security issues, right? So say you have developed your API, you have developed your application. How do you make sure that when you deploy that application to your server, how do you make sure it's secure? So the first thing is so one of the main mistakes developer, what they do is when they host a web application, they just SSH into the server, and they just do a git pull from the repo where they have hosted or where they have written the code, and the whole application code will get downloaded to that folder where the server is actually hosted. But along with that, .git folders also will be exposed. So why is .git folder sensitive? Because .git folder, using .git folder, you can actually print back the source code even if you don't have anything else. Using .git, you can use a couple of tools and extract the source code. And if there are any secrets stored in that, you can actually see the secrets. And if there are any test files which are stored in the server, you can actually see like how do you test this? So
Yeah, it's already 4 p.m. But I think it'll take 10 more minutes to wrap up. So Nishant, just
yeah, Harshit, sure, yeah,
we'll go overboard by 10 minutes, but we'll try to close by 4:15 max.
sure, yeah. So there is this tool called DIRSearch, which actually what it does is it takes the IP as the input, and it actually brute forces that IP with a specific dictionary, right? So it has a dictionary of commonly used directories, commonly used files, .git folders, and so on. So I just run this tool. It is going to brute force at the end of 8085. It's going to brute force whatever it counters. So yeah, here we can see, okay, there is a /admin folder which was actually exposed, which we couldn't see just like if we just saw this page, it is just 404, right? But there are hidden files inside that directory. So it runs a brute force recursively on the subdomain or domain which you give, and it will figure out hidden files and showcase, okay, these are the hidden files and so on.
Yeah, so basically using the brute force, we figured out that there is a .git folder, right? So what do we do after that?
So yeah, we have figured out that, okay, there is Git is actually exposed. So how do we go about this? So yeah, so Git dumper is a tool. It's an open source tool which actually takes the input as the exposed Git directory, and you need to give a directory name here for all the data to be stored. So basically, it creates a I'll just stop this. I'll just stop. Yeah, so basically this has downloaded a couple of objects from the server.
Okay.
And it has created a folder called admin where all the Git objects are going to be present. We just go to cd admin. We can see the Git folder which was.
Okay.
Yeah, we can see the Git folder which was actually present in the server which was exposing it, right?
So what is this extractor?
So basically dumper, what it does is it dumps the Git files from the exposed server. It just dumps the exposed files. So it has dumped config, index, logs, head, and so on, right? Okay. But extractor is the tool which is going to show you, which is going to reverse engineer the code which was actually in the Git.
Okay, so you're telling me that for the dumper, we basically, if we go to the dumper once again, so if I run the dumper once again, so this will basically create a folder.
Which will create a folder and it will download all the Git related files from the server, which is exposed. And extractor is the tool which is going to reverse engineer the code, okay, and give back. Yeah.
Got it.
And the next tool which we are going to talk about is the next issue which we are going to talk about is Aquatone. Basically, Aquatone is a tool which actually can figure out subdomain takeovers. Like, what is a subdomain takeover? So there is a subdomain domain which has a CNAME, which is a common name pointing to a different service, right? So I can use Zendesk or I can use a S3 bucket to host data. So that has a CNAME. And after the applications, after it is done, I do not remove my CNAME, and it can be claimed by anyone. So basically, what happens here is that an attacker can claim that domain which is actually free, and can host content on your website. So say there is a domain called appknox.com, which is pointing to Zendesk, appknox.zendesk.com, and Appknox has not registered or has expired the Zendesk portal. What it means that an attacker can actually claim that portal and he can host data on that. So Aquatone again is a tool which discovers all the appknox.io, star.appknox.io domains, and it is going to check if it is vulnerable to domain takeovers. So here we can see there is a potential domain takeover, and which is hosted on the service called support.appknox.io, and the service is Zendesk, and the CNAME is appknox.zendesk.io, which is actually not claimed. That means there is no appknox.zendesk.io. So when I create that, I can host contents on support.appknox.io. So that is the last issue, right?
Yeah. So I have another question after all of this, right? What I wanted to know is how would a developer figure out that they are actually, pasting keys? And so this is something which I talked in the beginning of the webinar. Like you will be also showing where developers are pasting keys in their Git, and how would you figure out that there were sensitive information and things like that?
Yeah. Thanks for bringing it up, Shubho. So basically, most of the companies will have a DevOps pipeline, or they will have a SDLC process, right? So this is what happens. You develop this, you deploy this, test this in UAT, whatever. There is a standard procedure. Like, so after the development, what developers can do is they can actually, there are a couple of tools which can be used to query the Git organization or the SVN repository to figure out if there is a secret key exposed. It can be a secret key, it can be a password, it can be API key, it can be a Slack webhook URL or whatsoever. So that tool is going to flag saying that, okay, whatever code you have committed to this repository, it has 3-4 secrets exposed and you need to fix it. So after completing the development and testing and all that, there should be an additional check on. So I'll go ahead. So GitDrop is a tool which actually checks for GitDrop is actually a tool which checks which takes a repository name, which takes an organization name as an input, and it starts a web server and it retrieves repository from each individual who is present in that organization. So for example, here these are our developers in our company. So it will what it's going to do is it is going to look into each and every commit which the user has done, like all the commits and all the repositories and so on, and it's going to say, okay, I have figured out just stop right here. And it's going to say, okay, I have figured out there is a settings.py file, and it can contain a database credential or secret. Basically, it has a lot of signature. It matches the signature for a password or a key or whatever, and it will say, okay, I have found this file exactly, or I have found the password and so on. So this also has a very good interface, web interface. You can just click on this. You can see the file on GitHub. View what is the exact commit which needs to be removed. Where is the password exactly being exposed and so on. You can. So this actually does not have anything. So yeah, using these tools, you can actually improve not leaking your secrets or credentials in Git or anywhere.
Okay, got it. Thank you so much, Nishant, for joining this webinar and helping us out in showcasing what are the basic API security issues which you have been working on. I think it was good figuring out all the things which you guys have been doing. Harshit, do you want to take it ahead?
Yeah. So I'll just end in a minute. So first of all, thanks a lot everybody for joining. I would request you all to help us with poll. I've just we have initiated one poll, and I think uh, uh, from the poll we can see that okay, people were expecting for a more like like more scenario based approach and probably more complex scenarios and all. So what we'll do is we'll do another follow-up webinar where we can talk about it and discuss more on those topics. Apart from it, we'll also send a mail. So would request all of you to like give us detailed feedback that will help us improve, make the next webinar more relevant for you. And for like upcoming webinar we are doing in January, so we'll be talking about mobile application obfuscation, and we will have someone from obfuscation industry probably talking more about it. So we'll get back to you with more details once we have everything up and ready. But till then, thanks a lot for joining, and I hope this was helpful. And we'll take feedbacks positively, and we'll try to give you more relevant content that you are expecting. So again, thanks a lot for joining, and thanks a lot for like giving us the feedback and all. And I'll wait to hear back more feedbacks over email as well. Thank you. Yeah, so we are closing the webinar. Thanks a lot, everybody.
Yeah, and we'll be answering all the questions.
And we'll send over email, plus the video link will send over email and tool details as well. So you can take reference from there and probably read more about tools and also get more details on how to use the tools and all. And in the same email, we'll also send you the LinkedIn group invite. So anybody is interested, we can have discussions over there. And if people are looking for more advanced scenarios, I think we can take it up over LinkedIn channels as well. All of Appknox security team is there to answer plus share their details and all. So thanks everybody. Thanks. Have a great day. Thank you.